now. Thank you so much again for joining us. My name is Lauren. I am the Volunteer Program Specialist at eCYBERMISSION. And for our 5th CyberGuide live chat, we're going to be talking about what it's like to be a cyber guide and an engineer. So engineering is definitely a big part of the eCYBERMISSION competition. And for these live chats, we really like to feature STEM experts who are cyber guides with us. So we have a few of those experts here with us this evening. And just for an overview, if you have not been to a CyberGuide live chat before, we usually have 10 every year. They begin in September and they go all the way through February, right before our team starts submitting their mission folders. They're just a chance to ask questions, to get some inspiration, or STEM inspiration, as we like to call it, and get a chance to just connect with eCYBERMISSION staff, our CyberGuide experts, and other teams from all over the country. So I'm really excited that you're joining us tonight. So tonight we'll be talking about what it's like to be an engineer. Some of the things we'll be addressing are maybe the differences between science and engineering and how they overlap. And to start us off, we're going to learn a little bit about the kinds of projects that engineers work on. So I'd like to welcome our first cyber guide tonight to tell us a little bit about what it's like to be an engineer. Cyber Guide Ryan, we would love to hear from you.
Hey everybody, can you hear me okay?
We can.
Okay. Hey everyone, I'm Ryan. I'm a mechanical engineer for the U.S. Army Research Lab. So I did my bachelor's degree in mechanical engineering and then my master's in mechanical. And my new job title at the U.S. Army Research Lab is actually biomechanical engineer. So some of my personal interests, like outside of engineering, are investing, business economics, history, basketball, roller coasters. So yeah, a lot of the time there's like a stereotype, like the engineer who's, really focused and only interested in their work. And that's really just a stereotype. Like engineering as a career, you can still have a really well-rounded and diverse like personal life and go after the things that you're interested in. So why do I like engineering? Most of all, like for me, I get the opportunity to work on like super cool problems. And these problems that I'm working to address, they actually impact the health and safety of other people. So it's making a pretty direct impact in other people's lives. So I'll take next slide, Lauren. So I mentioned I was a biomechanical engineer. So what is biomechanics? Bio refers to biological or living systems. And then mechanics is a word, as Galileo described it, to describe force, motion, and strength of materials. So the human body, if you look at your hand, it's made up of materials, right? And they have certain force and motion and loading like limits that they can handle. So if you've ever had like a broken bone, like the loading limits were exceeded and that bone broke. So it's kind of similar to that. Next slide. And yeah, I've read before, like one of my old professors, he said, maybe biomechanics was the first field of science and engineering, because just a very primitive observation, the harder you hit something, the more likely it'll break. So we see the pictures of like the cavemen, like really when they were using clubs and ancient warfare, a lot of that was like biomechanics. So another photo I add here is like early uses as far as suits of armor. So if you think the giant knight in armor, like that's very bulky, very heavy. One of the early inventions to kind of reduce the weight was chainmail. And chainmail, it actually gives you really good protection because you have this metal sheath covering your skin, but also very good mobility. It's not super bulky and not super heavy. So yeah, there's plenty of examples of biomechanical engineering, primarily in warfare in ancient times. Next slide. So specifically at the Army, I'm working on combat helmets. And this is just kind of detailing the combat helmet over, thousands of years. So they were using helmets in ancient Greece and then in Rome. And then that's a photo of like the Crusades time period. So maybe around like 1000 AD, still wearing helmets. And then you see the helmet is still there in the next one, but the guy is holding a rifle. And if you've ever had like history class with like Revolutionary War, there's a British soldier, and no longer are they wearing helmets. It's just like the trifold hat. So the bottom row there is U.S. military headwear, and you see in the Revolutionary War they just wore hats, and Civil War as well. And that was because the rifle really made the helmet completely redundant on the battlefield. The old like steel or bronze face covering, it wasn't enough to stop a bullet. But in World War One, trench warfare occurred, and that really saw an explosion of the use of different types of mortars, cannons. So there was a lot more shrapnel on the battlefield. And for little pieces of metal and shrapnel, the helmet was actually really helpful in protecting the wearer's head. So you see a reintroduction there. World War II, it's mostly like a steel pot helmet, so pretty much just shrapnel protection. And now we have the modern combat helmet. So this is a padding system to protect against concussion. It has Kevlar or polyethylene outer shell, so it can actually stop rifle rounds. And it's just a superior protection. And today you can't imagine a soldier who wouldn't have a helmet on in combat. So next slide. So this is very specific to what I'm working on in the Army Research Lab. So we want to understand how can we make the helmets protect against concussion better. So a lot of this involves testing different prototypes, running a lot of experiments in the lab. If you've ever seen a car crash commercial, like the crash test dummies, we use those quite often. And there's some limitations to using the crash test dummy. So you can see on the bottom of the slide here, there's like an example of the backfall test or getting struck in the back of the head. That's the M2. But we really want to know, what is the soldier seeing in the field? Like, if we want to protect against concussion, we need to know, like, what is the concussion threat to the soldier? So within the last couple of years, we've done a lot of studies with soldiers wearing instrumented mouth guards. So the soldier is jumping out of the helicopter or aircraft, and he's coming down, and they're taught to land and fall to their side. And there's a good picture here. That's a guy doing a parachute landing fall, it's called. And you can see like his head is probably contact to the ground. And we've identified that as a pretty big threat to Army airborne soldiers as far as concussion. So we're using the mouth guards, and using that data, we're trying to design combat helmets that protect against those loading. So it's really like a back and forth relationship where you're pulling data from the real world, and then experimentally in the lab, you're trying to protect against those threats that you observed in the field. And I think that might be it, right, Lauren? Yeah. So please send questions in the chat box, or feel free to speak up if you have any, and I'd be happy to answer them for you. So thank you.
Thank you, Ryan. Really appreciate all of that. That was incredible. It sounds like you have a super important job. So thank you for keeping us all safe. Looks like we do have a question in the chat about what software you use.
Yeah, so those plots that I showed on the previous slide, it's a software called HyperWorks, and it's actually used mostly for finite element modeling. But yeah, I found that it works really good for real life, like high speed video. And you have the video there and you have the data, and then you can like synchronize it and make a video that's synchronized, so you can see where you are in the data trace. So yeah, HyperWorks, it's called. Yeah.
Awesome. Thank you. And guys, if you have any questions, feel free to unmute yourself or put them in the chat. And looks like we have one from Arjun. How long have you been working in your job, Ryan?
So it's been about a little over 2 years now, like 2.5 years. I started August of 2019. So yeah, almost 2.5 years.
Awesome. And this one's just for me. Uh, if you work for the Army, but you're not a soldier, does that mean you are a civilian?
Yeah, so we have, there's people on the military side that are in the Army, and then there's also civilians. And Army Research Lab employs a ton of those. But I'm actually technically a contractor. So I don't have like a contracting agency. I'm just like a research fellow. So I'm not actually a full civilian yet, but there's like a there's a line like from military to civilian, and I'd be happy to answer any more questions about that.
Awesome. Thanks. There's always stuff to learn for all of us. Any other questions that you guys can think of?
So no, I'm not in like the Army Reserves. So I went to school. I got my graduate degree in engineering, and then I was hired by the Army Research Lab to come in and do engineering for them. So strictly engineer, employment at will. No commitment to the Army like itself. Yeah.
Love these questions. And how many of you guys are actually working on an engineering project for eCYBERMISSION? You can just put a exclamation point in the chat, maybe if you're working on an engineering project. Curious to see what you guys are working on. Cool, love it. Awesome. Well, any other questions for Ryan? Give it a couple more seconds.
Yeah, and I'm on the Kronos platform. So if any of you are on there, you can feel free to reach out and ask me questions related to your project or career advice or anything like that. I'd be happy to help. So
yeah, awesome. So Cronus is actually one of the resources that eCYBERMISSION has for all students on a team. It's an app where you can connect with a cyber guide like Ryan to ask questions regarding your STEM projects. So if you're interested in the link for that, Catherine just put it in the chat there. You'll just follow that link if you are an eCYBERMISSION student, and you'll click join as student. You create a profile, and then you see, once you are in the system, you'll see a bunch of cyber guides appear who have similar areas of expertise to what your project is. So if you have any questions about it, it's the way to get those answered. So make sure to check out Cronus. We've also got a few resources in Cronus, like community forums where you can just post a general question to anyone in Cronus. And team advisors are not encouraged to join. It is more encouraged for the students to join. But if you are a team advisor and you're looking for resources, you can email, I'll put the email address in here, volunteerprogram@eCYBERMISSION.com, and you can kind of request access as a team advisor. But we really do encourage it as a student resource. So awesome. Well, let's hear from our next cyber guide. We have CyberGuide Cal joining us this evening, also an engineer. So Cal, let's hear from you about what it's like as an engineer.
Thank you. Can I get a quick mic check, please, too? Oh, good. Yeah. Thank you. So my name is Cal. I really appreciate being here tonight again. One of the things that I really love about these live chats, apart from sort of giving, the younger folk a little bit of insight into my day-to-day basis sort of routine, I also enjoy hearing what the other engineers are doing, because many of us have studied similar things in school. I just saw Ryan, he studied mechanical engineering as well. I'm a mechanical engineer in my role, but we don't necessarily do the same type of work at our respective labs. So I wanted to point out that as a mechanical engineer, or any engineer in general, we're always having different roles and using what we learn for different applications. So right now I work at the C5 ISR Center at Fort Belvoir, which was formerly known as the Night Vision Lab. Most of the work that we do involves testing sensor and thermal equipment that gets installed into different types of vehicles that the Army uses and sends out to be used and field tested. My role for the lab is to integrate and execute different mechanical problems. As an engineer, and any engineer besides mechanical engineers, we're just certified problem solvers. We go to school, we learn how to conduct the engineering design method, which involves, asking yourself a question. How do we get from a question to an answer? We have to conduct some research. We have to form hypothesis. We have to test our hypothesis with different types of prototyping and testing. We have to analyze the data that we get from these tests, and then we have to go back and see, how do we fix it? What's going wrong? How do we go back and sort of mitigate any of the problems that we saw happening during the data collections. And then after that, we go ahead and rerun these tests again. And we slowly improve upon what we just learned from everything until we have a very good final product. You can go ahead and go to the next slide. So a lot of my day-to-day as an engineer involves modeling and simulation. So as an engineer, sometimes you may have to design certain parts or certain real life parts that you may have to design and fabricate. A lot of what I do involves rapid prototyping for vehicle integration. So we need to come up with very fast solutions that can be field tested for data collections. And these data collections provide us with information that we need in order to improve our technology. Part of what it means to be a modeling and simulation engineer involves creating high-level technical drawing packages, making edits to parts, testing these parts, picking certain materials that might work and may not work depending on the application. We may find ourselves making parts that may go out to extremely hot temperatures and different environments. So we may have to analyze to see if the parts we make can survive high shock, high vibration, high temperature, any sort of liquid that may come from rain or snow or any sort of environmental risk. So there's definitely a lot of different factors that you have to think about when you're designing a part, because parts are sort of designed to fail sometimes. And from that failure, you'll go back, fix it, and then improve upon that. As an engineer in the Army, you'll communicate with a bunch of project managers who are in charge of whatever mission you're a part of, government contractors, like Ryan just described he was, technicians who provide you with feedback for the parts that you make and how you can make them better, fabricators that create the designs you make, vendors who are there to sort of supply the software and hardware and additional supplemental parts that you may need for your parts. And in order to build a high quality mechanical solution, you have to take all of these different factors into account. We can go into the last slide, or second to last slide, I think. So again, when it comes to designing, there's a lot of factors and a lot of math involved as well. So you'll definitely have to figure out where things need to be placed, certain integration points. You'll also need to conduct testing. If you guys look at the left picture and visual, this is sort of a prototyped bracket for monitor displays. And as you can see, we created these very quick turnaround clamps that can be adjustable. And instead of maybe using simulation software in order to sort of confirm that it might work with the load that's being used, we may want to physically create a prototype to see if it'll fail. And we may want to also like simulate it in real life when it reaches failure so that we know exactly what the maximum load or stress is that causes it to sort of fail. We can go to the next slide. So again, like I said, I do modeling and simulation. So once you're done with the modeling side, you need to go into the simulation side, where instead of maybe you have a little bit of extra time to really put down and analyze what different factors might affect the parts you make before you field them. This can help with mitigating cost and risk, as well as time that you may want to, save for making more prototypes or making design changes. Here, I kind of have some visuals of contour plots that show exactly where, when a stress is applied with certain boundary conditions, where do you find the most and the maximum stress being, taken. So usually for these plots, you create sort of your own conditions that involves, static conditions, loading, moment, and whatnot. And then you'll use the data that you have to make assumptions and conclusions later on. So yeah, like I said before, we're pretty much problem solvers, and we're using the research that all the engineers get from the beginning to solve high level problems. So if you guys have any other questions, feel free to reach out and put it on the chat, or reach out on Cronus. I'm always available to help out.
Awesome. Thank you, Cal. Looks like we do have a question for you in the chat. In your job, do you use any math that you had to take in college? And if so, what kind of math do you use every day? And what kind of math do you need to study to get a career like what you have?
That's a very good question. So like I showed in the previous slide, when it comes to designing, you do need to have a little bit of a good grasp on geometry and algebra, so that because you might be using angles in three-dimensional space. So I believe that the three maths that I think are most crucial to at least my type of mechanical engineering would be algebra, geometry, and trigonometry.
Awesome. Thanks. I love these questions. Continue to put questions in the chat, y'all. If you can think of anything you'd like to ask our engineers, this is the perfect time to get any of those questions answered. And Cal, the last slide that you have on analysis, is that software that is just exclusive to your job? Or is that software that shows graphs that like anyone could use? It's kind of open source.
So this is ANSYS mechanical, which is it's given to us in sort of a student version from school. So it is available online for people to get. I know they have free trials for limited times. And then obviously, if you're trying to learn how to use the software, they also have tutorials online through their YouTube for you to kind of navigate through how you can simulate problems like this.
Awesome. Are there any modeling software systems that you used maybe in your undergrad that were free and available for anyone? Or can you think of any of those resources that are just like open source completely for modeling?
So at work, we usually use SolidWorks and Creo, which are not free, but I'm sure there is also Autodesk, and Autodesk has different versions of modeling software that have free trials online as well. I know that if you go online and you Google as far as basic 3D modeling software, I'm sure there's a couple of smaller packages that aren't as complex but can do 2D and 3D problems.
Awesome. Thanks. I really appreciate it. Well, guys, I love the stories that you guys shared about your job. Thank you for providing those resources. Continue to put questions in the chat. And if you have any that you'd like to ask, you can also unmute yourself and just ask any questions. But I really appreciate Ryan and Cal joining this evening, telling us a little bit about what it's like every day as an engineer And thank you for the innovation and the projects that you work on to keep us all safe and make the world a better place. It's really awesome to see what you guys are working on. Any other questions you guys can think of, feel free to put in the chat. I do want to mention that we do have another live chat coming up before the Christmas holiday. It's hard to believe that December is on its way, but we'll have another live chat on Wednesday, December 1st from 7 to 8 p.m. Eastern time. And we'll be kind of moving our focus a bit from engineering and more looking at building experiments for those that are pursuing a more science inquiry path for your project. In the meantime, if you have any questions, you can email missioncontrol@eCYBERMISSION.com. And at the moment, I would love to show you guys a little sneak preview of Cronus as well. So we mentioned it a few times this evening. Cronus is, again, a mentoring software platform. You can either use it on a desktop or you can use it on an app. And basically, it is a program where our cyber guides, who are our volunteers and who are experts in STEM, like Cal and Ryan, can create profiles, kind of telling our students what they are experts in, and then the students can come in and ask them questions. So again, I'll put the link in the chat for any student that is looking to join. You can just click join as student to create your profile. And I will show you, once you log in, you can actually see some of the resources that we have, like the community forums. So coming up on December 8th, which is also a Wednesday evening, we'll have kind of an open forum in the community tab where you can come and ask any questions that you have about the mission folder, or just any question you have about eCYBERMISSION and how it works. So keep that in mind. Wednesday, December 8th, come and hang out in the Cronus community tab. It's loading, but it looks a little bit like this, kind of like a message board. So if you have a question, you can click start a conversation and just type any question that you have. So on December 8th, eCYBERMISSION staff will be hanging out in there for an hour in real time, so you can post your questions and get quick answers right there in Cronus. So we hope to see you there. And thank you so much for joining this evening. If anyone has any further questions, feel free to put them in the chat. I'm going to go ahead and end our recording, but I want to thank everyone for joining this evening, for participating in eCYBERMISSION, and thank you especially to our cyber guides, Ryan and Cal, for showcasing what it's like to be an engineer. Hope to see you all again on December 1st, and good luck on your project.